So welcome everyone to the first lecture of AI Context Engineering Bootcamp, or more specifically speaking, LLM Context Engineering Bootcamp. So I know that the people who are attending this course are from many different backgrounds. I had received several emails from product managers, engineers, people who are students and industry professionals. So if you can just briefly mention in the chat, like, what do you do? Are you a engineer? What type of engineering? Or are you a student? Or what do you do right now? If you can just briefly mention that in the chat, I think that will set a good idea about what type of population exists here in this bootcamp. And also one more thing is, many of you are from different parts of the world. So for some people who had messaged me earlier that the time zone difference will make it difficult for them to attend the live lecture, but they will be able to go through the recording. Okay, I can see many different types of people who have commented. Many of them are students, many of them are engineers, software engineers. But I also know that several of them are AI product managers and traditional product managers. So I hope all of you are having a good time. So I'll just first set the reason why we decided to conduct this bootcamp, and then I'll first discuss a little bit about the logistics, what we will be doing in the upcoming lectures. When exactly do we meet? What all topics do we cover? And each lecture, how does it look like, etc. So I want to ask a question. How many of you have ever used any coding agents like Codex or Cloud Code or any other, maybe Copilot, or internally there are other softwares that teams use, or Cursor, anything. So you might have noticed that especially in the last 2 months, the way that these tools have exploded in its ability to actually do things, actually do very difficult things, it's so mind blowing. So especially we at Vizuara, we spend, in my opinion, maybe 90% of our time these days on Cloud Code with Opus 4.6. And it really helps that um, the same account that we have. So we have a $200 per month subscription, which can be used by multiple people. But as individuals, that will be difficult. But the point that I'm saying is, the way these tools have become today is such that I think many people who are working traditionally in software roles or in traditional engineering roles, the traditional role is going to become obsolete, in my opinion, and something new is going to emerge. And we have been spending a lot of time building various tools in the last few months that I realized that the most of the amount of time that I spend is in figuring out how can I give my input in the best possible way to the large language model, so that I can get the best possible output. So first and foremost, I want to share an article with you. This was an article that exploded in popularity in the last, I think, 3 or 4 weeks. This is by Matt Schumer, and this already has around 85 million impressions. I will share the link to this article. Although it looks like a big article, it is actually incredibly well written, and I strongly believe that every single one in this call should read this article. So I'm just sharing the link in the chat. Just save it for yourself and you can read it later. I think it's like a 10-15ish minutes read. It's really, really beautifully written, and I think whatever has been mentioned in this article about the changes that have happened in AI from last year or last to last year to now is humongous. So if people are not really building in this space, you will not notice the difference, because you may not notice the difference between when you're using ChatGPT in the normal chat mode versus when you are actually using coding agents to build stuff. So, today itself, when you have a chance, please read through this article. I think it will open your eye. Now, let me first ask you a question. What do you understand about the difference between context and prompting? Because when you are prompting an LLM, also you are providing an input, right? Versus when you are talking about context, it also includes prompting, right? So in your opinion, what is the difference? Just in 1 or 2 sentences, what makes context a much more complex word and much more a word that requires much more attention? The main difference is that prompt is the part which user gives, right? User is inputting something, but then the large language model has access to so many more things apart from what the user gives, right? So as someone has mentioned, context equal to prompt plus memory plus external knowledge base. Yes, it's kind of correct. There are more elements, of course, but context is much more wider. It has got much more to do with than just the user. And the engineer who is working with an LLM should know how to set the context to the large language model in such a way that you get a very good and desired output. So for those of you who don't know me, who are attending our bootcamps for the first time, my name is Dr. Sridhar Panat. I am a PhD from MIT from 2017 to 2022. Before that, I did my dual degree from IIT Madras. And since 2022, I have been working with Dr. Raj and Dr. Rajat as part of Team Vizuara. Many of you might know us through LinkedIn or YouTube and places like that. If you don't know us yet, this is the team. So the structure of this bootcamp is in the following way. There will be a total of 8 sessions, and the first 8 sessions will be conducted by me. And this is the rough syllabus. So today we'll be looking at the mental model behind what exactly constitutes a context which LLM ingests. What are the 6 core elements of the context? So with this, we will discuss today. And then following today, tomorrow, we will discuss system prompts which go into the context, RAG pipeline. So day 3 will be dedicated to RAG. Day 4 will be primarily dedicated to MCP. And then day 5 will be, some of you might have heard or read that Cloud Code is really good at compressing the context or compacting the context. It's also really good at figuring out when to clear the context and when to compact the context. So that we will discuss on day 5. On day 6, we will discuss memory, and then some patterns that we have to follow in production and how to evaluate the merit or how good the context is. In all these sessions, I will show you the structure, what exactly will we do in terms of foundational knowledge or theory, and in terms of hands-on exercises, what we will be doing, that I will show you in a moment. Then my part will end with session 8, which will be a build project. And I have several 2 or 3 different projects in my mind. I'll be picking one of them. And the details of the project I will reveal towards the second half of this bootcamp. So these 8 sessions will be conducted from Monday to Thursday. So this week, the first 4 sessions will happen from today, which is Monday to Thursday at 9:30 a.m. By default, I have defined the lecture duration to be 1 hour, but I can imagine that several lectures can go above 1 hour. Then the next 4 sessions, session 5 to 8, will happen next week, again from Monday to Thursday, same time, 9:30 a.m. IST. And then session 9, so session 8, there is a small thing which I'm thinking. If the mega project that I am thinking is becoming a little bit more complex than what I'm expecting right now, I may need to push the session 8 to one of the weekends, because I might need more time with you, not on a weekday, but on a weekend. But if nothing changes, session 8 will be next week, Thursday. Then session 9 and session 10 will be conducted by Dr. Raj and Dr. Rajat. And both of these will be mega projects where you will be purely building. Nothing will be taught, but you will be building along with them. The exact date and time of these sessions will be updated later next week. So this is roughly how it looks like. So at the end of this program, what I'm hoping is for you to take away the art of thinking about the context that we provide to large language models. And hopefully you should also be figuring out how to build agents for your own purposes. So Saurav has asked about WhatsApp groups. So I have started a Discord server. I don't personally use WhatsApp very frequently, but I have started a Discord server, and the link to the Discord server has been posted in the 2 courses, one for the engineer plan and one for industry professional plan. There is a question, would session and 9 and 10 be 3-hour sessions on the weekend? So yes, so what I will discuss this with Raj and Rajat regarding the timing, but you can expect it to be 3-hour sessions. And if it is a 3-hour session, most likely it will be on a weekend rather than on a weekday. Session 8 also most likely will go for easily about 2 hours. So that's the only reason why I'm thinking, should I push it to weekend or not? But that I will confirm later part of next week. Yes, in the capstone project, we are expecting you to build along with us, because you should also have the experience of building things for yourself, right? Everyone should be able to participate in the capstone project because it will be through the lecture only, but the content associated with it will be available to engineering plan students and industry professional plan students. This is the rough format of each session. So I have planned 3 things in every session. First is foundations or theory, which we will go through. And this part will most likely be kind of, you will find it easy, because context engineering is not strictly physics, right? Context engineering is more about the best practices that have evolved as a result of communities usage, as a result of recommendations from different big companies like Anthropic, Google, OpenAI, etc. So the foundations or theory are more like, often you may feel like, oh, these are thumb rules. It can go either way also, right? There will be a quiz session where I will walk you through certain multiple choice questions. My goal with this quiz session is to make sure that all of you are registering the things that we discuss in the lecture, so that you store it in your long-term memory. The third part, which will be part of each session, is hands-on implementation. In hands-on implementation, I have designed 2 aspects. One is pure Python code. So for example, in today's session, I have a Python code which can be easily executed in Google Colab, but you will have to give your API keys and few other things. I will discuss that in a moment. But before the bootcamp started, several students had messaged me and industry professionals had messaged me saying they are not very proficient with Python. So will they be able to follow in the lecture? So what I have also created is these interactive web notebooks, which will cover the exact same concept that the Google Colab is covering. So during the lecture, I will be going through this interactive notebook so that everyone should be able to visualize what is going on in the exercise that we are doing. So everyone, regardless of your coding experience, whether you're good at coding or whether you're bad at coding, you should feel comfortable. But this Google Colab notebook, I'll be sharing immediately after each session so that you can implement the exact same thing which we implement during the lecture through these interactive notebooks in Google Colab also. The only difference is that in this, some parts of the code are abstracted away. It happens in the background, not in the foreground. Now, a few things about the large language models, the API keys. Okay. So before coming to the API keys, these are the things, the frameworks which we will discuss. And these frameworks are not like it came out of some textbook. I have gathered these frameworks from many different sources. Andrej Karpathy has pioneered a lot of ideas that we will discuss in this course. Founder and CEO of LangChain, founder and CEO of Shopify. Then many other community members have proposed very different workflows that have become famous. Recently, OpenClaw has become one of the fastest growing GitHub repositories in the whole world. How many of you have tried OpenClaw, by the way? If not on your personal computer, at least in some other isolated computer. Have you tried building a personalized agent for yourself using OpenClaw? At least you should know about OpenClaw. It has taken the world by storm, and the way it works is also way the most of these tools work is by providing very good, very rich context to large language models. Yes, scared to use it. Of course, you should be scared to use, at least for the time being, because it's not very, you don't know what it's going to do if you are exposing all your personal data to an agent that sits in your personal computer. Because of that reason, although I have used OpenClaw in our other machines at our company, I have not installed it personally on my laptop as well. So today we will discuss about LLM OS analogy, which Karpathy had discussed in one of his talks that he delivered at Y Combinator. This was a few months ago. That talk had so many views. I will share the link with you. Then we will discuss in the next lecture the write, select, compress, isolate framework. Anthropic has another idea called write altitude. When you are constructing system prompt, how detailed should you be or how abstract you should be? So there is a write altitude principle. Then there are ideas like product requirements prompt. When you are building a product with pure AI agentic coding, how exactly do you give your prompt so that the output is something which you expect? So last week I had released one lecture video on our YouTube channel. It was titled as building like an agent for accumulating news, AI news from different websites. So I forgot the exact title of the video, but basically what I'm doing there is like I'm building an AI agent which will automatically look at different sources on the internet. So it will look at GitHub, it will look at Archive, it will look at Hugging Face, it will look at Reddit, various subreddits, x.com, LinkedIn, and then it will aggregate all the hottest topics that are happening at that point, and it will give it for me, so that instead of me having to go through a lot of noise to read about things that are happening in the AI LLM agent space on a daily basis, I just need to go to my website and there I can see everything in one place. So that I'm building. Almost 70% of the building is done. So just check our YouTube channel for that. So there I talk about a little bit of details of how to set up Claude Code workflow. But there also you will come across several different concepts like RAG, or storing things in the persistent memory, system prompts in the form of cloud.md files, which we will also be discussing in this bootcamp. And then React framework, reasoning and acting framework, which has become very popular since I think 2025, early part of 2025. And then budgeting the tokens, because your token, the context window is limited and finite. And also talking about what are the different types of memories you have when you are using LLM for a large number of iterations or large number of back and forth conversations. So the prerequisites are the following. The way I have constructed this website and also the Google Colab notebook is such that it works for either of the three API keys, Anthropic, OpenAI, or Google. Somebody asked whether we can also work with Olama or any other API keys. I can change the website, this interactive website and a Google Colab notebook in such a way that it also works for other APIs, because the way in which API keys are used in the function calling is different for each of these three. It's slightly different. So I need to take that difference into account to make it workable. But by default, if you have either of these three API keys, it should work for you. I personally don't have an Anthropic API key, although I use Claude Code. I don't have an API key. I only work with OpenAI or Gemini API key. So just make sure that right now, if you want to go through this exercise once we reach that part in today's lecture, just make sure that right now you go ahead and make sure that you have either of these three API keys. Okay. So for Anthropic, if you are taking API key, you can just recharge for a minimum amount of credits, $5. That is fine. That can be the case with any of these. And to get the API key, just search, if you're looking at OpenAI API key, just search that on Google, follow the links, and it's very kind of straightforward process. But this API key, one of these API keys will be necessary for all the lectures in this series. So the sooner you get it, the better. The other things are a little bit optional. You having a little bit of experience calling APIs or HTTP requests, having a little bit of experience working with JSON file formats, those will be okay. I mean, it'll be good to have, but even if you don't have any experience working on JSON files or HTTP requests, etc., it's fine. I'm expecting most of you to have some level of proficiency in Python. When I say proficiency, I don't mean to say years of experience. I mostly mean to say you have used Python in some capacity at some point in your life. And make sure that you have Python installed on your computer also, because every single exercise we will not be conducting on Google Colab. The reason why I have created this Google Colab document is because I figured that many of you might not have all these things right now. So I thought Colab is the easiest way to share the code and help you execute the code in the fastest way. All right. So let's first discuss about the difference between prompt engineering and context engineering. So prompt engineering is basically very simple. You are the user. Let's say you are going to chat.openai.com, which is the ChatGPT website. And there you are providing the prompt to an LLM. Let's say you want to build a code base for implementing some deep learning pipeline. Let's say you want to implement vision transformer using a Google Colab code. You will give some prompt like, I am so-and-so. I am a teacher who is trying to teach vision transformer. I would like to have so you will mention who are you, what should the LLM act as, and then to what level of detail should the code be? Should it be extremely long? Should it have comments, or should it not have comments? Because if you are building the code for teaching someone, the code should have sufficient number of comments and markdowns so that people who are going through it, people who are seeing it for the first time can understand. But if you are simply using it for implementation, you probably don't care too much about the code being really good or easy to read. You want it to work. So the prompt which you give to the user will include the instruction, right? It will probably include, in some cases, trial and error or some examples which you give. Okay, there is one question: which one of these API keys not only efficient but also affordable? So for most of the exercises that we will do today, the cost you will incur per API call will be less than maybe $0.5. Not per API call, cost per exercise will be less than $0.5, which is like what, 45 rupees, right? So throughout the bootcamp, any API keys with maybe $10 to $15 credit will be more than enough for you, for most of you, I think. Then when you craft the prompts, right, are you looking at one shot success, or are you looking at success in few shots? So one shot meaning you give one set of instruction and you want the LLM to give you a successful output in one shot. So if it is in one shot, you give more instructions, right? You say, hey, here is an example of one such code I had created earlier. Provide me something like this. So in prompt engineering, basically input is basically a text string. Your goal is to craft those text, which as a user, you should craft it in such a way that it helps the LLM produce the best possible output by knowing your intent. You cannot call the large language model multiple times at once. You can only make one API call at a time, because you are going to the chat, you are asking a question, which means you are making one API call with the inputs, and you can't do multiple API calls. And this is something that is good for a beginner, but as an engineer, you should be moving away from prompt engineering. You should be moving to context engineering, where you have a lot more control. So what are some of the elements that form as part of context engineering? One is, of course, which I have not explicitly mentioned here, is user input. So the user input part will, of course, be there, just like normal prompt engineering into the context engineering, in context engineering also. But beyond that, sometimes you will have to retrieve documents. So I will tell you my reason why I decided to start this bootcamp, the specific reason. So I'm trying to build an AI agent which will help me process many of my emails. So there are roughly maybe 200 plus emails being received every day. And if I have to respond to the emails in a timely manner, I have to spend at least 2.5 to 3 hours per day just on the inbox. And this is a major time sink, because then I won't have time to work on anything else. So all of us are planning to build an email tool, email reply agent, which can be as good as us. So it's very different when the sort of emails that you receive are highly technical, right? You might also notice this, like if you want to build an AI agent to, let's say, reply in your work Slack or in your work Discord or whatever platform you're using, it cannot be a generic, just an AI chatbot. It should have a lot of background information about your project, who you are, what you do, etc. So if you were building, let's say you were running the company Vizuara, okay, and you are getting bunch of emails about different programs or different courses, or maybe many companies want to partner with you. What all elements would you consider here? And the goal is I want to build a chatbot, and this chatbot should basically craft responses to the incoming emails. And me as a user, the only thing that I have to do is tick, which is approve the crafted response, or decline, or ask it to regenerate. So regenerate the response, one of these three. So with one click, I should be able to manage responses. So if you were building something like this, what are the different aspects that you will consider? So one question is, why don't we use OpenClaw? It's a great question. The only thing is, OpenClaw I am still not confident enough to use OpenClaw for our internal tools. I can use it if none of our emails or those things are not exposed. But even if we use OpenClaw, what are the different knowledge bases that you should have? So let's think about this, right? If you have a website, if you are a company selling a product, or if you are, let's say, an educational organization like us with bunch of courses, so you need a lot of details about everything that is there in our website backend, correct? And this, because many times the questions might be anchored around, hey, when does the context engineering class start? Will Python be required? So there are a lot of questions surrounding around courses. And let's say on our website, let's say we have 5 dozen courses. A lot of courses are there. So this info we need. What is the other info? What else would you need in the context? So another thing which you would need is your email history. Why do we need the email history? Because if I consider the email history from last 1 year or last 6 months, there is a certain way in which I respond. My way of responding is to some questions I'm very concise. It's very short reply, but to some questions that require longer responses, it's a longer email. And that is my personal preference. So somehow from my email history, these personal preferences should be learned, right? Then there is one more thing. So this email history, somehow website information should be concisely mentioned in some sort of metadata. Because if there are, let's say, 100 courses, I cannot load the 100 course related information into my context because my context is limited, by the way, which we will come to in a moment. So I have to have some metadata saying there are these many courses, this is the link to this course, something where metadata is some smaller version of the original data. Then email history, if I'm looking at the emails from the last 1 year, maybe there are 10,000 threads of responses, threads where there are at least one response. So this email history, I cannot entirely load into my context. That also will again kill the context. So I have to have a concise form of email history. But there is one more thing. One more thing is recency. So, or we can call it as recency bias. Basically, what this means is the last 20 emails or last 30 emails that I have sent contains the latest information about whatever we are doing, right? Because the email from 1 year back might have some outdated information, but email from 3 weeks ago will have more recent and more correct information. So recent, let's say 20 emails have very high value. What else do we need? Some things could be like rules. Rules are something like if let's say some course has 2 different links. One is like a link with the course name, one is like the link with the course ID. Always give the user the link with the course name because course ID based link is let's say confusing. So there are a bunch of rules that you might want to say, or some rules are, yeah, exactly, guardrails as Vishnu has said, or some rules could be something like the last date for any particular bootcamp is maybe 1 or 2 days after it starts. After that, it has to close. So if somebody asks, that should be the response. So there are, let's say, 10 different rules which are globally applied across all the conversations. On top of all of this, we have to have some feedback system such that if I deploy this application in the production, if the email response that is crafted by the tool is not very good, I should be able to say, hey, this is not good. I'm rating this 1 out of 5. Then I should also be able to give a reason why did I rate it 1 out of 5. Another way for giving feedback is, let's say the email agent crafted an email, but then I did not like the second last sentence in this email. So that alone I edited. So now from this information, if the email I have slightly edited in this section, there is something for the LLM to learn from this, right? Not in terms of fine tuning. There is something to be provided in the context based on this change that I made. So some feedback should be there. And also some RAG should be there, retrieval augmented generation. Why is that? Because if the person who is emailing is asking about one specific program, then that specific program's detail is somewhere deep buried inside our website details. But first, a RAG pipeline should fetch, let's say, top 3 courses that are relevant for this student or whoever is asking. Then it should re-rank. So it may fetch top 10 or top 15, then it will re-rank and then provide the top 3 course related details into the context. Now, when I keep saying context, what exactly do we mean? It simply means you have a large language model. You know that large language model takes text input, right? The text is converted into tokens and the tokens pass through the LLM. And then ultimately it is about next token prediction, and it will predict a sequence of tokens, which are the output from the LLM. So when I say context, in its crudest form, context is simply what is being filled in these tokens that are part of the large language model input. So then the question is, how do I fit my website metadata? How do I fit my email history in a concise way? How do I fit my 20 emails? How do I fit my RAG output? How do I fit my rules and the feedback, everything into this context window? Along with what? I'm missing one thing here, one important thing. What else is missing right now into the context? The email itself, the incoming email to which I have to respond. So that which is technically the user input. So that email also should fit into the context. So now all these things should fit into the context. Now, if you have ever tried to build a tool like this or a Slack chat bot for yourself, you will realize that it is not at all easy to make it respond exactly the way you will be responding usually. It's not at all easy. Sometimes it will hallucinate. Sometimes it will be over enthusiastic unnecessarily. Sometimes it will not provide enough information as much as you would have provided if you were responding. So it's not at all easy. And we have been spending tremendous amount of time perfecting this so much so that we can also release it as a product where anyone, if you are running a company and if you want to deploy an email responding agent, you should be able to do it with a few mouse clicks and a few data sharing of a little bit of data. So while figuring this out, I also realized that it is very hard to understand how to set up the context for the large language model to get an output which you are expecting. So that is one of the reasons why this bootcamp came into existence. Okay, there is a question. I think email is an input and website top courses are the real context. LLM will respond on input email based on the context. So LLM will respond based on the entire context. In the entire context, the incoming email is one of the things, is one of the inputs. But the rest of the things are output from your RAG, the email history in this specific case, the metadata from the website, the specific rules, the specific feedback. And you should notice one more thing. This feedback, as I am keeping on using the tool, this feedback will keep on growing. Because what if I give 10,000 feedback over the course of 6 months to this tool? I cannot fetch 10,000 feedbacks and expect it to fit into my context, because that will again cause LLM context to become useless, right? So these are some of the things that we should actually engineer properly if you have to get some tool which looks simple to actually work. So you might have noticed Gemini giving some example suggestions for replies, right? In emails, you might have noticed it. Gemini, it has some context, but it's only useful, like in my experience, 1/5 of the times that response crafted by Gemini is useful, but 80% of the times it's not useful. So that was another reason why we decided we should build our own internal tool. Memory is needed for this kind of application. Yes, of course, memory is needed. Do we also need skills in the context engineering? So David, I hope you are asking about the skill.md files. Is that what you're asking about? Yeah, we will need that also. It's one of the parts of context engineering. If feedback added for each interaction, or is it in batch? So currently I'm adding feedback for every single interaction, because my goal is to make the tool better and better with use. Okay, my question is to LLM. We are sending most junk data. How can we reduce to get precise answers to reduce the token limit error? Yes. So we will be discussing that. Very good question. Now let's come back to our main discussion. So the user input is just one of the things, meaning from our email example, the incoming email is just one of the items that goes into the context. There are many other things that go into the context. RAG, in our example, RAG retrieval is the retrieval of the, let's say, course related data. System prompt will include so many things about my own writing preferences, the style with which the email has to be crafted, who is the user. So in tomorrow's lecture, we will go into detail how the system prompt, which famously is stored in cloud.md files, especially for those who are using Cloud Code, CLAUDE, cloud.md files. So we will discuss tomorrow how system prompt exactly looks. Then there are a bunch of tools. So in fact, I have built an MCP, Model Context Protocol server, which again we will discuss in fourth lecture in detail, for fetching information from our backend server. So just with natural language, I should be able to fetch information. I should be able to process the information. And this is very different from making an API call, right? So currently we are also using MCP. There is a memory. There are two types of memories, persistent memory and short-term memory, in which the information regarding latest emails and last 1 year worth of emails metadata is stored. There is conversation history, because if I'm, let's say, having a thread with somebody, that thread has a history, right? That person has already talked about a lot of things with me. I should not chat to my LLM as if it's a new conversation, or the LLM should not respond as if it's a new conversation. And then, of course, guardrails, dynamic examples, which is a subsection of RAG, will be part of it. So this is just one example. In your company, you might be building something completely different. But in general, agents are taking off in such a big way, because right now the way the context is constructed by default in OpenClaw or in Cloud Code or in many other platforms like Lovable, you might have used Lovable to build a website front end. It's amazing. With very minimum input, Lovable can create very beautiful output. And Lovable is also, at the end of the day, using one of the LLMs. It's not like it's having its own LLM, but the context that is set for some sort of full stack or front end development in Lovable is in such a good way that even with a very small user input, it's able to produce such a very good output. So that is, in one word, what we can say. In prompt engineering, as a user, you are thinking in one dimensions, but whereas in context engineering, you are thinking about multiple different dimensions. And we will, in this day one context lab exercise, we will figure out the importance of each of the 6 elements of the context. So in 2023, okay, what separates our builder application from OpenClaw? OpenClaw also does the same, right? Yes, Mohammed, I hope you are asking about the email news aggregator tool which I had built, right? Or are you asking about something else? Are you asking about email response agent? If you're talking about the email responding agent, the main difference is that you need to construct some OpenClaw also can in effect do it, because it's an agent. You can have memory for the agent. It can have access to your Gmail, and it can do everything. But then you should know what all things are you going to provide to its context. You can't provide a 10 megabyte JSON file. Usually JSON files are very small in size, like it's in kilobytes, right? But when I downloaded the past 1 year worth of emails, each month, so 1 month email was roughly anywhere between 10 to 20 megabytes, the JSON file consisting of the data. Like that, if I have around 13 months, then that is anywhere between maybe 150 to 250 megabytes of data. Now imagine the size of the length of those JSON files. If pure text is contributing to 250 megabytes of data, it's humongous. It cannot fit in the context. So we have to have our own engineering to figure out how best can we fit all of this data, or what from this data should be fit into the context of the large language model to provide you the output, irrespective of whether you're using Cloud OpenClaw, or whether you're using Cloud Code to build your own application. So in 2023, you might have heard a lot about people talking about prompt engineering. That was the buzzword at that time. Then Andrej Karpathy coined this term vibe coding in just one tweet, and then everybody started talking about vibe coding. And then everyone is now talking about context engineering, and especially now that the AI agents, especially coding agents, are becoming so good, I really, really urge you, if you have not, to use Cloud Code with Opus 4.6. Has anyone tried this combination, Cloud Code with Opus 4.6? So this will not work in the free plan of Anthropic. You will have to at least go with the $20 per month plan. But this is my honest feeling. Sooner or later, everyone is going to switch to one of these, either this or Codex or one of the coding agents. The sooner you do it, the earlier you will move ahead of the rest of the people, simply because it is so good. If you are a student, you should figure out from your institution whether you can get a discount. If you are a working professional, I think this money you should take from your pocket if your organization is not giving it, and it's completely worth it. It will save you. If I had access to this in my PhD, 50% of the time was gone in analysis of experimental data, writing the papers, making the figures. Doing the actual physical experiment was the other 50%. I now feel like if I had access to this back in 2021 or 22, I would have saved at least 2 years of my time. I'm being very honest here. So you should definitely try Opus 4.6 plus Cloud Code at least once in your sometime in the upcoming weeks. I think you will never ever code yourself anymore, like from scratch. So this can you tell me what's the difference between vibe coding and context engineering? Is it kind of the same, or is there some subtle difference? So in vibe coding, the way in which you work is to give you a good example is, if you want to build a website front end, and if you are using Lovable, you give your prompts, right, and it will produce some output. You may or may not like it. You will do it again, and you will give again feedback, and then you're hoping that after a few shots, the output you will get as a result of vibe coding is something which you will like. So you're not coding explicitly as a programmer, but you are more like sharing the instructions to the large language model based on what you see as from its output. In context engineering, however, maybe the vibing part is there in the user instructions. As a user, when you're giving prompts, yes, maybe you're probably doing it based on your feelings, etc. But most of the other 5 elements of the context engineering, it's pure engineering in the sense that you should have a RAG system in place that has very low latency, and it should be very, its metrics should be in such a way that whatever it fetches should be relevant to the context. You should have tools or MCP which are relevant to that particular task which you are trying to do. So in our case, the MCP should give us access to the entire Firebase storage or Firestore database. And if there are persistent memory and if there are short-term memory, that memory, we should decide what goes into each of those memories, what is persistent and what is short-term. We should explicitly decide those things. You cannot vibe code. You can try vibe coding the markdown files, which are there as part of this, which we will discuss a bit later, but it will not be as good as you explicitly engineering it, right? So in this talk, I will share the link. This was, I think, 2025 towards the end. Andrej Karpathy delivered this talk at Y Combinator. Former director. This is a very nice talk. I think you will get inspired if you listen to this. Just 40 minutes. I'm just sharing the link in the chat. So in this talk, he gives an analogy between, he has talked about it in many different places also. You can follow him on x.com. So I don't think the link got shared. 1 second. You can see the link in the chat, right? I think earlier I put it in waiting room. So Andrej Karpathy has coined this term where if you look at an operating system versus large language model, different components of large language model can be compared to different components of an operating system. So a CPU, which is the processing unit of an operating system, can be compared to the LLM model itself, GPT or Opus 4.6 or whatever you're using. Then let's look at the other parts, okay? So the agents which you build, which can execute tasks, are like various applications. So on Mac, if I'm using, let's say, Zoom, or if I'm using some other application for taking notes, this Miro Notes, there is a Mac application for it. Those are different agents which can perform one single task. Then the way I make system calls to those applications are similar to either API calls or like tool calls through MCP, Model Context Protocol. So I don't know if how many of you have heard of the term or are familiar with the term Model Context Protocol. So bear with me until we reach that lecture. For now, just understand that Model Context Protocol is the standardized way in which large language models can interact with various tools or softwares, for example. So if you want to connect your Slack with ChatGPT, you can use Slack MCP. And then to ChatGPT, you can directly ask, hey, look at the channels where I am yet to respond, right? So this is a natural language command. And that command, using that command, using MCP, LLM can access different channels in your Slack. And then from there, it can get details. And that details can be passed into ChatGPT, which it will process and give you a natural language response. And then file system, which are stored in your computer, which will be loaded into your RAM during the processing and which will be processed by the central processing unit, can be considered as an equivalent of vector databases which are used in RAG. And finally, context window is compared to RAM. Can anyone tell me why is that? Why is context window equal to or equivalent to RAM in an operating system analogy? So two things are there. One is RAM is not a permanent memory. Second, it's not an unlimited memory. Both constraints are there, just like context window. So context window of top large language models these days are like on the order of million tokens. But those million tokens will not remain always the same. Those tokens will keep changing. Plus, that million is finite. The moment you load certain number of documents, your context is done. So let's try to discuss that. How many words do you think make up one token? One token equal to how many words in English language? So I can see many different responses. One word. So the approximate answer is one token is equal to 3/4 of a word. Approximately. I mean, it's not exact, but roughly 0.75 words. Okay. Now, by that logic, if we have a context window whose size is, let's say, 2 million tokens, how many words or how many pages worth of data can we fit here? This can be easily calculated. So if 2 million, first of all, in one page, how many words are there approximately in one page of a book? Approximately how many words are there? You can say roughly like maybe 300 words, depending on the font size. Because a big paragraph or like a short paragraph is around 100 to 150 words. The abstract of one of my papers during PhD was 150 words. So 300 is like two such paragraphs. Now, depending on the font size, some of them will be 500, but let's keep it as 300. So one page is 300 words. Okay. Now, 300 words is equal to how many tokens? Or let's do one thing. One page is equal to 300 words. So 2 million tokens is equal to how many words? One token was 3/4 of a word, which means 2 million token is 2 million multiplied by 3/4 words, right? So this is 6/4, roughly 1.5 million words, correct? Now 1.5 million words will be roughly how many pages? It will be 1.5 million divided by 300, right? Which is equal to 1.5, or I can say 15 multiplied by 10 to the power of 5 divided by 3 multiplied by 10 to the power of 2, which is equal to 5 multiplied by 10 to the power of 3, which is, am I correct? 5 multiplied by 10 to the power of 3, which is 5K pages roughly. I hope I haven't made any silly calculation mistake. But just look at this. Now, this is the context window size of the large language models that you have around these days. It can fit 5,000 pages. There are some models which even have like 19 million tokens, which means it can fit roughly 10 times this, around 50K pages. So then a natural question that can come is, if the context window size is so big in large language models, why do we care about engineering the context? Because how often do you sort of use a 5K page document in your context? Why should you care about engineering the context? Okay, many people are saying cost. Why do you say cost? Can you just elaborate? Okay, I understand cost, but cost is the cost of usage of large language models are proportional to consumption of tokens, right? So number one issue is cost. Equally important is one more issue, which is, yes, latency could be another issue, but even more important issue is something called as context rot. So your context quality will be degrading as the number of tokens in the context increase. So to say that context engineering is, let's say, not needed simply because the context window size is so huge, the analogous part of that compared to operating system is like saying software engineering is probably, we don't need database organization so much because I have, let's say, 2 TB of RAM. If my computer had 2 TB of RAM, it's not like I suddenly don't have to manage my database or I don't have to manage my RAM, right? It's not like size of it is not uh, making you want to manage it. In fact, the more your context window is, the more capable and more powerful your large language model is, which means increasingly you will be doing more and more complex tasks. And because of that, you will have to learn how to manage the context. So there is a paper called, not paper, there is a very nice article written by Chroma on context rot. Just have a look at this article. This is also very nicely written. It's not a very long article, came out around mid of last year. So this they had a paper which showed quantitatively how the context rot happened as the number of tokens increased per context. So yes, so somebody has commented MCP also has context overhead due to too many tool descriptions. Exactly correct. So we will be seeing that on lecture number 4. When you have 50 plus tools in your description, if your LLM has access to that many tools, your context will be bloated up with just the descriptions of tools, that the rest of the things in the context will be overwhelmed by this tool descriptions alone. So these are some of the LLMs and its number of tokens in the context: GPT-4o, GPT-5, and look at these 3 models, Cloud Opus, Gemini Pro, Meta Llama 4 Scout. This has around 10 million tokens in the context, which is roughly 28,000 pages. The Gemini 2.0 Pro is like 5,000, roughly 5,000 pages as we calculated earlier, right? And GPT-4o can fit around 300 pages. So here again, this is a bit challenging because you sometimes can pass PDF documents with 300 pages into the context of a large language model. It sometimes happen, right? But this is very unlikely. This is also very unlikely. But even then, you should definitely not exceed the context. If you are using Claude Code, you should be familiar of a command. One is /clear. This is one command. Another is /compact. So what /clear does is, which we can discuss during the building stage, but I'm just saying this so that you can keep this in your back of the mind. /clear command, what it does is, if you are switching your task within the same project from, let's say initially you were writing an article, then later in the same project you are working on a website, then you should probably use clear command to completely clear the context. Actually, in Cloud Code, there is a very nice GitHub repo which you can utilize called Cloud Mem. This is for efficient utilization of memory, and this has so many stars. For those of you who plan to use Cloud Code, you should definitely know about this GitHub repo. The installation instruction is provided down here. Just it's very straightforward. Just go through it. It can be installed as a plugin. So this will help you manage memory between sessions, which will again help you with having a good context. Now, this point we already discussed. If context window size is so big, why do we care about context engineering? Because you still cannot pollute your context, because then the relevant information will get flooded in the irrelevant information. So there are 3 different type of definitions. One by Andrej Karpathy, who said the delicate art and science of filling context window with just the right information for the next step. This is one type of not a definition. It's more like it's the way he personally visualizes context engineering. Tobi Lutke from Shopify, the art of providing all the context for the task to be plausibly solved by LLM. Basically the same thing. Then Harrison Chase is the CEO of LangChain, building dynamic systems to provide the right info and tools in the right format. In my opinion, this is slightly more specific definition of context engineering. I like Karpathy's definition a bit more in philosophical way. Then this key principle sentence I have directly borrowed from one of the blogs from Anthropic. Anthropic has a very nice blog on context engineering. Find the smallest set of high signal tokens that maximize the likelihood of your desired outcome. All right. Now let's look at this token budget. So this figure is showing you token budget. So in the exercise that is upcoming, what we will be doing is keeping track of the token budget and looking at 6 elements, the bare prompt, which is the user input, then the next layers, the system instruction, then conversation history, retrieved knowledge from RAG, the definitions of different tools that LLM is having access to, and the state and memory. How each of these 6 layers will affect the quality of the output is what we are going to do in today's exercise. But we will not do it all at once. We will do it in steps. So first, we will look at the quality of an output of, let's say, a chatbot if it had only access to users' input. Then second, we will add instructions on top, system instructions on top of it. Third, we will add conversation history on top of it. And then we will see quantitatively, if we were to quantify the betterment of the output of the LLM, how it looks like, that we can see. But here, this is how usually when you see a context visualization, Cloud Code also has a context visualizer, which will show something like this. Even in our website, there is one visualization I just want to show you. So here, if you scroll down a little bit, there was one visualization in which all elements are not there, but you see the context is shown as filled due to different elements. So this context is the input, which will be tokenized into the LLM. It will have a limit, 128K tokens or 2 million tokens or whatever. Within that, each elements of the of your prompt, system prompt, RAG, user input, etc., will keep on filling it. All right. So this is an example of each of the things. So retrieve knowledge. What do you retrieve after RAG? For those of you who are familiar with RAG, after RAG, what exactly do you retrieve after re-ranking? You have chunks, right? So in RAG, your knowledge is converted to chunks. Chunks are converted into vector in vector databases. Then certain number of chunks are retrieved. Then they are re-ranked. And then maybe you will pick top K or whatever number of items you need from those chunks. Those chunks will be, let's say they are in sentences. If it is a sentence of 10 words, it will consume how many number of tokens? Roughly 3/4 of 10, right? Roughly 7 to 8 tokens it will consume. So if there are 8,000 tokens as shown here, and let's say there are 10 chunks, it means each chunk has 800 tokens, which means each chunk has roughly 800 words. If we were to roughly say one token is equal to one word. So 800 word means each chunk is now a huge paragraph, or maybe it's a combination of like the statement of purpose that a student writes when they're applying for grad school is 1200 words. 1200 words is like 2 pages. So 800 word is like 1 page and a half. So here 8,000 token, if it is constructed through 10 chunks, it is like roughly 10 chunks with each of size 1.5 pages roughly, right? So that is what retrieved knowledge will look like. Tool output is, let's say you are using a large language model to track some price of some stock. So let's say some stock market website is giving you MCP server to fetch the stock price. What will you ask your large language model? You will ask, hey, can I know the price difference between NVIDIA stock from last month to this month? So this instruction is a natural language instruction. This instruction will tell, using the tool description, that I have to call the, let's say, finance tool MCP. And then within that tool, after you call the tool, you will get certain response, and the response will look in certain format. And that output from the tool will also be passed into the large language model context. So that output will typically look in this format. It won't look like paragraphs and like chunks. If you have conversation history, if you are running a chatbot, and if the chatbot should have persistent memory within the conversation, the entire conversation between user assistant, this should be passed into the large language model context. So if there are 10,000 tokens, it's roughly 10,000 words. I highly doubt if any chat between customer and user will be 10,000 tokens. But if there are multiple chats going on, and if all of those should be loaded into the context, which I don't think no one should ever do, but if that is the case, then you can imagine it to be that many number of tokens. And typically, the current query which user is asking will not be that long. If you imagine the way you are asking to ChatGPT, what is the typical size of your ask to ChatGPT? Unless you are copy pasting something, your typical ask is one paragraph. One paragraph is maybe 100 words, maybe 200 words, something like that, right? Which means it's on the order of hundreds of tokens. So current query will be a small part. Look at the fraction. Let me zoom out a little bit. Look at the fraction that this is contributed. The total tokens here are around 28K. Total budget is 128K. Out of the 28K, the prompt engineering part is only taking care of this 500 tokens. That's it. But 500 is only like a small part of 5 divided by 28.5. 0.5 divided by 28.5. It's a very, very small fraction. So the rest of the tokens are coming from your system prompt instructions, your memory and state. So in this case, the memory, we will see if it's a customer, what does memory mean? Okay, Vishnu has made a statement, file attachments can be part of the current query. Yes, if file attachment is part of the current query, if the file is like a 300-page book, then this will be very high. Then this 500 token will become very huge. Usually what is done is files like images are so heavy in tokens, which is the reason why the more you pass images into your large language model, the more expensive your usage will be. But if it is just a text-based PDF, usually OCR tools will convert it into digital format, and then only it will be passed into the large language model. If videos are input, then no need to say, it's like amazing, like your context is absolutely bloated up. There is a question, can we say the phenomenon of context rot is the reason why RAG applications is an option? Thus, reason why, even though we can push massive documents into LLMs, it is best if a RAG system is built of it. Yes, that is a very, very good way to think about it. Even if the context window becomes, let's say, 100 million tokens in the future, you will still not be passing very big tokens, very, very large number of tokens into the context of a large language model, because the performance will definitely degrade. You yourself think about it. If you are building a website, okay, in some parts of the website, you will have certain preferences as a user. In some other parts of the website, your preferences may be different. So let's say here your preference is to use font size 50. And here your preference is to use font size 20. Okay. It may so happen that if everything is fed into the context without any reason, you yourself may give contradicting instructions, like this and this might contradict each other. I have a perfect example for this. So we have a personal ChatGPT account, which me and my wife are using. Both of us are using in the chat. Now, she is pregnant. So when she is using this thing, she is asking questions regarding, why, like, what's the reason for this nausea and issues like that. Then yesterday, when I was using, I asked some question regarding, I forgot what it was about. Then it was responding to me. It was in a new chat. It was responding to me considering I am pregnant. It was giving me some weird responses. Then I was like, what's going on? I thought this was a new context if it is a new chat, but that's not the case. Internally, ChatGPT is taking care of the context in such a way that, it is assuming that the whole chat is made by one single user. Thank you so much. Thank you for your kind words. So this issue won't happen, by the way, if you are making API call. In the API call, automatically context is set by you yourself. There is user, but apart from that, there are system instructions. Now, let's say in the system instruction, you have provided your website, let's say preferences. I want this type of font style. I want this type of font family. I generally prefer modern dark color theme or bright color theme, something like that, you yourself might contradict when you move from page 1 to page 2 of the website. So this you will clearly experience when you are building something yourself. And that's a classic example of rotting of the context, because you are bloating the context with too many things. Is there a video or a link on how to effectively use Cloud Code? Yes. So we ourselves plan to launch. There is one video which I had recently released as a playlist last week. You can check that there. I'm building an entire website from scratch, just using Cloud Code with Opus 4.6. But we do plan to release more content on Cloud Code, simply because I'll tell you honestly, 3 weeks back, I had a time when I had sleepless nights. I was waking up at 4 a.m. and then I could not sleep till like for the rest of the time. And I had taken a promise that I will not touch my laptop before 8 a.m. because then there is no boundary between work and life. So then from 4 a.m. to around 8 a.m., I was just walking in the room and outside my building, just thinking about the sort of agents I could build. And this happened because I could see the power of Cloud Code with Opus 4.6, what it can build. And I felt some sort of excitement, which I had felt last maybe in the first or second year of my PhD, when some experiments became successful. At that time, I had gotten a very big kick, a high, and similar kind of high now I'm feeling after like 5-6 years. Of course, there are other highs, but it was very different. So I hope each and every one of you in the call, when you start using it, you will get some sleepless nights and you will feel like building something on yourself. It's truly amazing. I can't say more. So this we already discussed, right? The 6 elements of the context window. Now this is the context rot many people have been discussing in the chat. So before going into context rot, I want to show you one more paper. It's called Lost in the Middle Effect. I think I have it already open somewhere here. Yeah, this one. So this paper came out in 2023 end, and this already has around 3,500 citations. It's a really simple paper, by the way. I feel like if we had the same thought, I could have also written some paper like this, because this is purely about, it's not about building a new large language model or anything, right? It's prompting a large language model through inference and coming up with a conclusion. So this Lost in the Middle paper, what they showed was, when you fill the large language model with context, with a lot of information, the information that are there in the middle of the context are typically some critical information that are loaded over here in the context window might get lost. Large language model place a lot more emphasis on the starting point of the context and the ending part of the context. Whatever is there in the middle is being lost. Now, if you ask me, why is this fundamentally happening? I don't have a great answer, because I know that when we are constructing attention scores, if we have 5 tokens, 1, 2, 3, 4, 5, you have 5 queries and 5 keys. And the whole idea of attention is that of long range dependency. So my attention weights will look like, it will look in such a way that every single query can pay attention to every single key. So there is no specific reason why the middle tokens are, the inference in the middle tokens are being affected so much. I don't know why that is the case. But from experiments, what is being clearly seen is that LLMs have this lost in the middle effect. So now what should be your goal as somebody who is creating the context for large language model? Your goal should be such that shrinking the context size in such a way that most of your info by default is coming at the two extremes, meaning shrinking this middle part as much as less as possible. So for example, if your context window is so large, and let's say LLM is losing much of information here and here, if you shrink it to this much, it may lose something, but what is lost is only limited to this much, right? And you ensure that no critical information is provided here. And usually when the different elements of the context are appended one after the other, user instructions come somewhere here, system instructions come somewhere here, rest of some of the items which are more dynamic come somewhere in the middle. And how exactly this works, I don't have a answer based on physics. It's just something that's based on experiments. But I really recommend you to have a look at this paper. It's very beautifully written. Just search Lost in the Middle Effect. Somebody had also posted about needle in the haystack effect. That was also something that was discussed in the haystack. So just have a look at, I think it came out more as a blog article. I'm not sure if this was just have a look at this blog article perhaps instead of the paper. It's also talking about very similar idea. Yeah, so lost in the middle effect is what are your main instructions? Your system instructions are some rules. Let's say your chatbot should never ever be condescending. Let's say that's a rule, which forms part of your system instruction. Where would you rather put it? Would you put it here? Would you put it here? Or would you put it here? Your chatbot should never ever make a mistake of not taking that information into consideration, which means that information should never go into the middle of the context. Now, how do you say something is in the middle of the context? You have, at the end of the day, context is a string, a sequence of tokens, correct? And inside the context, you have system prompts, maybe something like information from cloud.md markdown file. You have information which the user gives. You have information which are tool outputs. You have information which are maybe recoveries from a RAG. So typically, this system prompt is very important because most of your rules are set here. And you don't want your LLM to ever hallucinate on these things, which means if you are concatenating this plus this plus this plus this, you don't want the system prompts to be somewhere in the middle. You ideally want it on the starting or ending, and typically it will be in the starting. Similarly, user also is giving some instructions with so much importance. You have to give so much importance to the user, because otherwise, if you are literally conflicting the user's latest request in the response, user will not like it. So typically, user response is also provided in one end of the a prompt. And can we control this behavior through prompt engineering technique? You mean, can we control the lost in the middle effect, or can we control where these things are placed? Which one do you mean? Oh, can we control the lost in the middle effect? Unfortunately, so far, it is a thing. I mean, it's a thing that it's a problem that LLM has. So I don't know, other than shortening the context window size, I don't know what else can we do to completely eliminate lost in the middle effect. Does it happen for smaller context length as well, lost in the middle effect? For smaller context length, in general, it is not. So when they did the experiments, it was more pronounced in the larger context. So typically for context window sizes exceeding like 100K tokens, the effect is more pronounced. Where is the paper? Yeah, this one. Any proven ways to reduce or limit lost in the middle effect? The most proven way is making sure that your context is compact so that most of the information, 90% of the information are all important information are already there, either at the start of the or the end. Then reducing the context, making sure that the middle information are a little bit dynamic. So I'll give you an example. Let's say you are fetching financial data from a website about Nvidia's stock. Okay, it is sometimes okay to have a little bit of hallucination there. I'll tell you why. Of course, it's based on the on case-to-case basis. But if the tool results are a little bit hallucinated, there are already frameworks in place where once you get the tool result, you can verify it whether with something with whether it is what you are expecting or not. So in the MCP that I had created, for example, I could fetch any data from our backend database. And before acting on that data, I have other agents in place which will verify that whether the fetch data is something which is correct or not. So even if this wrong data has been passed into the LLM and LLM has given me some response, I am not immediately acting on it. But what would cause an issue is in the system prompt, I have mentioned that never ever write anything into the data without my explicit instruction that I have mentioned into the system prompt. Now imagine that system prompt was somewhere in the middle. Then when I'm using my MCP, the large language model may erase some data or modify some data in my database, which should never happen. So for that reason, such kind of crucial, critical guardrails I place such that it will come in the start or the end of the context. It should never come somewhere in the middle. Can we repeat the context engineering? Doesn't the needle in the haystack test whether model attends to all tokens in the context. Yes, correct. That's very much correct. Needle in the haystack means there is one token that is like the needle. Haystack is the whole set of tokens. Can the large language model attention scores or attention weights be constructed in such a way that does the model attend to even that token also, irrespective of where it is placed? Can we repeat the context with multiple different ordering of information? So Vishwanath, if I understand your question correctly, when you say can we repeat the context, do you mean the same information we repeat once more? Is that what you mean? Very good question. I recently came across a paper. I think it was from Google, repeating the prompt twice. Google paper. So in that paper, what they showed was if you give the same prompt twice to the LLM, I think it is this paper. Very recently it came out. Let me make sure if. Yeah, this is the paper from Google. So basically what this showed is if you have a prompt, you repeat the exact same prompt twice, and then this will it will increase the token consumption, of course, but it will tremendously increase the output quality of the large language model. And I haven't read the paper. I only came across the paper like 3 weeks back or something. I haven't read the paper. I do intend to read the paper, but I think it's a small paper. You might want to check this out. But this is very interesting, right? Somehow the context window is set up in such a way that when the prompts are given twice, it is somehow reinforcing the large language model, what the large language model is seeing. And the attention weights are constructed in such a way that if the prompt was only occurring once instead of twice, LLM is not able to as efficiently carry out the information. And yeah, of course, this is the trade-off between cost versus quality. Cost will be doubling, quality will also be improving. So what they did was very much this. If you have query like this, you literally paste it twice. So your user query token length is 2x of whatever it was. Take a look at the paper. It's very language of that is very simple. So usually what people suggest is, so this is the final recommendation, right? Should we have too many tokens in the context window or too less tokens? The problem with too less tokens is that model will start hallucinating because model does not have enough instructions to do what we want the model to do. If there is too much context, there is context rot. So in this case, if your model's token window size is 200K, anywhere between 50 to 100K can be considered as a sweet spot. Within 50, if it is 50 to 100K, remaining 100K tokens are free for model generation output, because when the model is generating an output, it also has to fill the context. It will fill the context. So you have to always leave some room for the model's output to be stored in the context. So with that point of view, if for this particular model is 50 to 100K, 200K is very good. Also, this is not a physics-based graph or anything. It's purely empirical. So now by extrapolating this, if you may ask, if it is between this to 2 million tokens, will the graph look exactly like this, or will the graph look something like this? It's very difficult to say unless you actually do the experiments, right? Okay, there is one question by Arun. Can you explain difference between context engineering and agentic AI? So if you want to build agents for various applications, context engineering is already a required part of it. However, every single thing that you do in context engineering may not be geared towards building an AI agentic application, because context engineering you have to do regardless of whether you have an agent or not. So one way you can think about how an agent works is, let's say you have a API key for Gemini, and let's say you are running a bunch of experiments on RunPod. This is experiment number 1. Then you have another set of experiments on RunPod, which is experiment number 2. Oh, that Google paper I did not share. Let me just make sure I paste it. So this is the Google paper. We just check this. So now coming back to the difference between context and agents. So let's say this is experiment number 2. And what you want is the following. You could either say something like something to the large language model, like run experiment number 1 first and run this second, right? And then you are sequentially executing it. You are executing experiment number 1 first, then its results are stored somewhere. Experiment number 2 first, its results are stored somewhere. Then you may analyze the result. Excuse me, just give me a moment. This is a little bit inefficient. The reason is, in fact, if you had an agentic framework, you could actually execute this in instead of in series, you could run this in parallel. So if you are working on a paper, a research paper, you will form a hypothesis. You would want to run a bunch of experiments. You will have to analyze the results, and you will have to make figures corresponding to this. And these days, many of these things can be done using AI agents itself. So how many of you have heard of this called Paper Banana? This is a tool which is made on top of Nano Banana, and it's really, really good. It's really good for making actual research paper level quality figures. I'm not kidding. It's extremely good. The only thing they have done is they have built an agentic framework around Nano Banana so that paper making can be efficient. Now, my question is, let's say while you are running this experiment number 2, okay, your experiment 1 is already finished and you want to make a figure out of this experiment number 1. But simultaneously, you want to run experiment number 2. What you do is you define 2 agents, one agent for figure making, another agent for running the experiments on Runpod or Google Colab or wherever. Agent number 2, and this is agent number 1. Now, each of these agents will have the access to the same API key. So if Gemini is what is being used, the same API key both of these agents will have access to. Now, here is my question. When agent 1 is making an API call to, let's say, Gemini or whichever model, and agent 2 is making an API call, is the context window the same for both of these API calls? The context window will not be the same because they are 2 different API calls. Agent 2 will have more context and more information about experiment number 2, whatever that is. But agent number 1 need not have details about experiment number 2 in its context. It needs to have only details about experiment number 1 to make figures corresponding to experiment number 1, right? So if you look at the overall framework, the 2 agents you have created so that these tasks can be done simultaneously in parallel, because it is just like how you have let's say you have 2 people working in your research team. To both people, you give the same API key. One person is using it for running Paper Banana to create some figures. The other person is using it for running some, LLM guided experiments on Colab or Runpod, right? So these you can call as sub agents also. And you are defining these agents so that you can do things in parallel, but you will not give the same context to both of these. So the context in the context engineering is also about the fact that although you have multiple agents here, both of these agents are not getting access to the same context. So in your agentic engineering, all you do is you define the agent, you define the tools and skills the agent has access to, and it will mostly do only one task. It will have an output in a certain format. This agent may have access to MCP. It will have some output which will be stored. So the AI agentic workflow will involve things around that. But in context engineering, in general, you can have n number of agents. You can have 100 agents. In Cloud Code, when you run, you might have seen it spin out sub agents. So what sub agents do is sub agent will create a new agent which will have its own context window, so that whatever is happening in another session is not affecting the sub agent's context. So you might notice that if there is a figure making agent, the figure might look very good, but another agent which is doing experiment number 2, maybe it will provide it can provide a poor result if its context has exceeded its context window optimum limit. So these are some of the things which context engineering will take care of, unlike just AI agentic engineering. I think now we are already running around half an hour above our timeline, but I think we can spend some time on exercises. So I don't want to go through Google Colab simply because I don't want you to get intimidated by looking at the code, although the code is not that difficult. The same information we can convey through this website. So I'm just sharing this website link in the chat. I will be changing the link later and putting it on the course website also, but just open it. And there is one place where you have to place your OpenAI key or Gemini API key. So just click this key icon over here and paste your OpenAI or Gemini API key. If you don't have the API key, you can just listen to the lecture right now. It's okay. So now this exercise is very simple. This exercise is supposed to show you the importance of different elements of the context engineering. There are 6 layers of context engineering, and this exercise is supposed to show you the importance of each of them, right? So this is the situation. There is a frustrated customer whose name is Marcus, and he's contacting the company Novatech Electronics about a headphone which this customer recently purchased of $18.99. Yes, I will share this link as well as the Colab link. So this is the website link, and so if you guys really need a different version of this so that you can use Olama or any other API keys, just let me know. I can make modifications, but currently by default, this code works on 3 keys: Anthropic, OpenAI, and Gemini. Website primarily works on OpenAI and Gemini. I haven't set it for Anthropic. Okay, so this customer is now coming and chatting because the headphone of $18.99 is defective, and the self-service option in the website is not working very well. And because of that, and then there was a 45-minute waiting hold on the call. So now it's like the customer is saying, I want to now do a credit card dispute, etc. And this customer is like a premium customer, meaning this customer has already purchased items worth of $12,400 from the website. So these background information is there. Now the task is this: we should go through each of the 6 layers. Excuse me, let me drink some water. So now our task is this: if we have a large language model who has only access to the system prompt, let's say, so this is our bare system prompt, not system prompt, bare user prompt. So the user is saying, based on the past conversation, no, the portal just gave me some same error. It wouldn't let me submit anything. So I called your support line and sat on hold for 45 minutes before I got disconnected. This is now my 3rd attempt to get this resolved. I'm absolutely livid. These are $18.99 headphones that I need for my professional work, and left ear is crackling. It's been barely a month. I'm about to dispute this on my card, and if someone doesn't fix this right now. So this is user prompt, user input. Now, if we are simply doing a traditional prompt engineering, there is nothing much to do because users input is this, and then based on this input, the LLM has to produce the output. But the LLM, ideally, in context engineering, it should have access to some conversation history, right? So this conversation history is like the user initially asking, hi, I need a help with a defective product. Order number is this. Then assistant will say, I would be happy to help with this. I can see this is for this headphone. What is the issue? Then the user is answering this. Then you'll say, thank you for these troubleshooting steps. The crackling issue is firmware upgrade and resets does sound like hardware issue. Let me look into the best solution, and so and so. So this is the chat that has happened so far. Now, what I have built here is we will be passing to an LLM. The LLM will be whichever we select here. So right now it is Gemini 2.5 Flash, Gemini API key I have pasted here. And based on this, what we will do is we will only pass one of these layers at a time. So first we will pass just the user input. So currently user input is 110 tokens, which is roughly 100-ish words. And the output is output of the LLM is analyzed for various parameters. So here, when I click running, oh, you are not seeing my screen right now? Do you see my screen right now? The interactive website? Okay, you do see? Okay, awesome. So when I run with just one layer, which is the user input, okay, this is the output that LLM produces. LLM responses, oh my goodness, I'm so incredibly sorry to hear this. This is an absolutely unacceptable experience. I can only imagine how frustrating. So a lot of fluff, nothing useful. Please accept my apologies, waiting for, this is like literally repeating what the customer has said. But if you really look at the resolution, there is almost nothing. Like, could you help me with the order number or email address? Order number was already provided to the chatbot earlier. But because the chatbot did not load the conversation in the context, the earlier conversation into the context, it has no idea what has happened so far. And because of this, if you try to grade the quality of the response, like whether it adheres with its persona, so persona should be empathetic, it should be helpful, etc., whether it adheres. And this I have manually mentioned on what factors should you grade the LLM response. Yeah. So there is a question: how are you calculating the hallucination and completeness metrics? So hallucination is, there is some knowledge inside the knowledge base over here, which I have not added yet, but the knowledge is about a refund policy. Knowledge is about if the customer has purchased something of greater than, let's say, $500 or something, the window of returns can be extended by 15 days. So these things are part of the policy of the company. And then the grading is done by, yes, exactly. So grading is done by another LLM. In this case, it's the same LLM, but with a different API call. So that for grading, it will have access to all the context, and then you can perform the grading. Okay. So it's just for us to see, but a human can also grade it. Then actionability is, this LLM offers no actionable steps, 0 out of 5. So overall, if you look at it, out of a score of possible 40, it's getting only 18. And this is simply because in the context window, only one thing is available, which is the user prompt. And user prompt, we should expect it to be perfect. Why? Because if you are providing a chatbot, if the customer is asking something to the chatbot, we cannot say, hey, customer, go and study prompt engineering and do this. We can't expect that. So this is perfect, which cannot be touched. Now what we do is we go to the next step. In the next step, we add some system instructions. Just a second. I have a bit of a sore throat, so that's why I have to pause a little bit to drink some water. So system instruction is, you are Alex, a senior resolution specialist at Novatech Electronics. So Alex is the name of the chatbot. You have 8 years of experience and authority to approve resolutions up to $2,000 without manager approval. Then, as I mentioned, in the system instruction, you have to provide the rules that should never be hallucinated on. Always lead with empathy and empathy before offering a solution. Use the customer's first name naturally in the conversation. Never say I can't or that's not possible. Always frame what you can do. Acknowledge every frustration. Then take personal ownership, not I will, the team will. I mean, instead of the team will, put I will. If the customer had a bad experience, explicitly apologize for it. Introduce yourself by name and your role. When you have policy details, cite specific numbers when proposing a solution. So these are some rules that the chatbot should live by. And you can notice that nothing is too specific in this rules in this system instruction. Nowhere it says, if customer comes back with a $1,899 headphone, say this. It's not saying that. And tomorrow we will see why are we not doing that, because it's too specific. There is one question: how did I implement the right hand metric card? This one, right? So the way it was implemented was using one more API call. So into that API call, I'm passing everything just for grading, because if an LLM has to act as a judge, that judge should get everything, right? So when you say use chat GPT 4.0, you got 14 out of 40 or 23%. Is it for the system? Is it for the first step with just the user input? Or is it with the more? Yeah, okay, that makes sense. because score will not be constant. Each time if I run also, it will be different. But now let's see with the system prompt how the score improves or whether it declines. So let's move to the second step. So one thing I have noticed while running this, sometimes it because it's not physics. Sometimes with system prompt, the score can degrade a little bit. In this case, now with the system prompt, the score is increasing, 23 out of 40. Yeah, when you say you call an API for the score, which API was that? So that API was also same as this. So here I pasted Gemini API key, same thing, same I use for the judge also. So I make two API calls. In one API call, I only pass the user prompt and system prompt. In the other API call, I pass everything. I pass all the details and how the judgment should happen. And then it will be used for judging the result from the first API call. And that judgment result is what is shown over here. Okay. And here now the score is 23. So policy accuracy, no restocking fee for defective items, context awareness, but actionability is still zero. Maybe no actions are being provided in the response. But some changes you can see. Here it says, hello, I'm Alex, Senior Resolution Specialist. So this is one of the system instructions. Yes, I can share the GitHub repo for this. The code base I have already shared, but I'll put it in a GitHub repo. How do you make the judgment is consistent across multiple calls? So the instructions that I have provided to the judge LLM is the same in all the calls. Whether the LLM will hallucinate itself during different calls or not, yes, there is a chance that hallucination can happen. So I cannot ensure 100% consistency from one call to the another. But since the judge LLM has most of the context, we can hope that it is judging based on objective metrics, not hallucinating. Then let's move to the third step. So third step will be adding one more layer of detail. One more layer of detail this time is the retrieved knowledge. So retrieved knowledge is this. The bot will look at the company policy document. So the standard returns window is General Electronics 30-day window. Yes. So whatever response we are getting. So here for each experiment, for each experiment, we are making two API calls. First API call is to make to be made into the LLM with the user input and whichever other input we are providing. Second API call is made into the judge LLM, and judge LLM has been given certain criteria by me, and judge LLM will judge the response which it received from the first API call, and that is how these scores are generated, right? So judge LLM knows everything. What constitutes a good response, what constitutes a bad response, it knows. Judge LLM can be another OpenAI API or anything else, doesn't matter. With system prompt, it should have given actionable responses, as Alex has the authority to provide a refund till to $2,000. That's not happening? Yeah, that's true. The main thing is it has no idea about the refund return policy or refund policy or anything because RAG is not there. So now we are adding RAG, retrieved knowledge, which is around 600 tokens. So now you see the token window has increased. In the first, it was user was just this dark blue. Then now we have this green, we have this blue, and now we have RAG knowledge and run with 3 layers. Now I want to show you this assembled prompt. Okay, so initially only this was there. Initially, only this was there. User thing is assembled at the end, but system is assembled at the beginning, and RAG is implemented in the middle. Implemented as in RAG is assembled in the context in the middle over here. So this whole thing is the prompt that is passed into the large language model. Okay. And now the score has increased slightly, 28 out of 40. But you look at the token consumption, initially it was 479, then it is 744, and now it is 1262. What if the inputs and response of the agent that is given to the judge LLM is beyond judge's context length? Oh yeah, very good question. In this case, that is not the case. But if it is beyond, judge won't be able to judge. Or if it is beyond the sweet spot, there will be context. Sumit is asking latency is also improving, some sort of caching. Good question. None that I have implemented myself. So I'm not sure latency whether it's improving because of deliberate prompting, or it's just an aftermath of having a better context. I'm not 100% sure of that. Prasanna has asked, so this whole context is assembled and passed as a prompt. Exactly. So this is the whole prompt. And now look at the score. So this is how the score looks now. Empathy and tone, context awareness. And if you hover your mouse on top of it, it shows why it got 4 out of 5, or why it got 3 out of 5, why it got 1 out of 5, right? And then we can add one more layer now. The next layer is tool definition. Tool definition is basically what kind of tools are there. If order ID is provided, look up order. Then process replacement for replacement of defective products, or issue refund for refunding of defective products, and issue service credit. And then context window has increased by another 300 tokens. And the tools are added over here, just below the RAG output. So what is at the start and end of the prompt again? Here, what is at the starting? System prompt is at the starting. What is at the end? User input is at the end. Everything is in between. The tools RAG are in between, and then run with again 5 layers. And why do we do that? To eliminate the context rot in the middle, not context rot, eliminate the lost in the middle effect. Eliminate or minimize. So now again, 30 out of 40, because now some scores are improving. No hallucination, 5 out of 5. No policy hallucination detected. Personalization, actionability is still 1 out of 5. Completeness, address the defect, address portal failure, address hold/disconnection. And you read the output. Output has increased in size actually. You have to scroll a lot to read the full output. Whereas earlier in the very first case, output was too small. Does this sound like a good resolution for you, Marcus? Just read through the output once. It's actually becoming better. And then the sixth step is state and memory. So now everything is there in the context. The user, system prompt at the top, user prompt at the very end, history of previous conversation, knowledge from RAG, tools, which are functions it can call, state, whether the memory is currently there or not. What is there in the memory for this bot as of now? Very good question. So in the memory, it is stored that this customer is a platinum customer because the customer has paid 12,400 in the past. The customer satisfaction level is this much. So it's like a loyal customer, and that is part of the state. State meaning what is the current situation for this customer, and it will be stored somewhere in the document, and that will be there in the current memory. And then look at the token size. Token size has become 1.9K, and look at where it is assembled. User, it's at the beginning. Not that. Context system prompt is at the beginning. User is at the end. Once again. Yeah. So system prompt is at the beginning. Then user prompt is at the end. Then the interactions between the user and the bot in the previous turns are over here. This one. So user assistant, then user assistant. So this is the previous conversation history. Can we try reordering this prompt and try? Yes, in the code that is possible to try. Here, I think I can add a tool to study the effect of lost in the middle. I can do it such a way that a system prompt is added later in the middle, but I feel like lost in the middle, for it to see the actual context window size is not 4K for Gemini. It's much bigger than that. So I don't think you will see the context lost in the middle effect with such small number of tokens. You will have to add more number of tokens. Are all memory implemented using markdown file only? I see this a lot in cloud. They all are stored as MD. So it's either most of the times it's MD or XML format. Or MD markdown format. So in most of our recent building processes, everything is stored as MD. In many cases, I have my big document stored as JSON files for structure, but I will often have a metadata of the JSON stored in another markdown file. Yeah, so now finally the score is, let me run with 6 layers. So one thing you should notice is that sometimes the score will reduce even after adding one more layer. Okay, I have noticed it, and to get a good example where the score actually keep on increasing is very difficult. The reason is this: if let's say it's a generic example, LLMs are already very good at producing good output, which means unless you have a very specific judging criteria, and unless you have a very specific conversation history and very specific knowledge base, your score may not keep on increasing. And even with all of this, if you run this 2 times, the output may differ because LLM will provide different output during different conversations. But on an average, the effect is what you see in this table. The score on an average will keep increasing with more input. So this is user plus system, user plus system plus RAG, user plus system plus RAG plus conversations, user plus system plus RAG plus conversations plus memory. And the score is the highest. Now, I want you to do one thing. I want you to go back home and try it in this Google Colab also. Yeah, score reducing is okay. Can you guys share a screenshot of your scores in the chat if possible? Like for your 6 experiments, how was the score? Like this. Did anyone get better than 30 percentage? So mine is not percentage, 31 out of 40. Mine is 31 out of 40 in the last attempt. It will also depend on whether you are using OpenAI or whether you're using Gemini. Oh, with all the 6 layers, Shivam, you're getting 20 out of 40. Oh, that is a bit weird. Okay, Sriharsha got 33 out of 40, which is very good. In real environment, our state slash memory and RAG share the same services or different? When you say services, what do you mean specifically, Sumit? Okay, Avinash has 27 or 31 in, I think, in the second last experiment. Yeah. And Nachamai has, I can't read the font. I think it's 23, 26. It went up to 26. Yeah. Oh, database instances. Is RAG and memory always stored as database? Not necessarily. RAG almost always has a database. For memory, we need not have a database like a vector database or something. It can be simply stored as a markdown file in your backend wherever you are deploying this application. So in our case, the email tool, the memory is the history of last 50 emails, which is stored as a JSON file. Now let's do one thing. I want to conduct a small quiz, which I think most of you will find very easy. Okay. There are 15 questions. Let's go through this. In the LLM OS, so this is just to refresh what we discussed in today's lecture. So every lecture, we will end with a small quiz like this. In LLM as an OS, what maps to the RAM? Context window, right? Fairly straightforward. Then in LLM OS analogy, what acts as the file system? Persistent storage, the model reads from on demand. Just read the full question. It is the RAG and RAG databases and vector stores. Can you tell me why is it, let's say, not the system prompt? Because system prompt is also a file, like a markdown file. Why is it not system prompt? Because system prompt is not on demand. System prompt is always there, whereas RAG database is always on demand. Then traditional prompt engineering, primarily, I mean, most easy question. What is it? It's the user's input is the only thing that traditional prompt engineering minimizes, optimizes. Which of the following is not the one of the 6 elements of the context here? So I can see 2 outputs, B or C. Is it structured output schema or model temperature? It is model temperature because model temperature and sampling is like top case sampling or whatever is something that has got to do with LLM. Model temperature defines from the output token how much variability is there when the final softmax probability score is predicted. Are you picking the one with the highest score, or are you doing some sort of search to find one of the highest probable elements, right? Highest probable tokens. So it's model temperature. It's not structured output schema. Structured output schema we will see when we describe, let's say, for example, when we define tools, we will define the structure. Tool result or retrieve knowledge is also part of context. An LLM app works in great in testing, but degrades over weeks in production. No code change. What has most likely happened? Token overflow, or because token can exceed your budget, of course, or is it model drifting? The model itself, LLM itself, is becoming worse over time. Or is it prompt injection? So many times what may happen is token overflow can be taken care of. You know how? When token reaches around 80% of the budget, you can auto compact, that we will discuss in one of the lectures, or you can entirely clear the context. But context rot can happen even before your context window become full. So your application can degrade even if overflow has not happened. That's the point. So context rot can happen more likely than overflowing of the token. But this can happen, but this is very rare. The lost in the middle paper, I mean, this is fairly, yeah, Cloud Code keeps on compacting, yes. And if sometimes it will compact only when 80% or something is reached, and the output becomes very bad. So then I often say slash compact very frequently when I need to switch from one task to another task. How many tokens does the phrase context engineering typically require with a byte pair encoding tokenizer? This word equal to how many tokens roughly? Is it one token or two tokens? You can say roughly two tokens, right? Because roughly one word equal to one token in BPE, not exact, but approximately. Then 1 million token context window, like Gemini 1.5 Pro, is roughly how many pages? So this is easy to calculate. So one token equal to 7 by 4, 3 by 4 of a word, or 0.7 times of a word. 0.7 of a word, right? So 1 million token is 700K words. If each page has, let's say, around 200 to 300 words, I can divide this by 300. So 700 by 300 is roughly 2.5 or something. 2.5K pages. 2.5K pages is close to 3K. So here we can say 3K roughly. So the C would be the approximate answer. This concept I have not discussed, so I will skip it. You have 128K tokens, you stuff it with 120K tokens of potentially relevant documents. What may happen to the output quality? Will it improve? Will it degrade? Model automatically ignores. Quality remains the same but latency increases. Mostly what happens is there is too much noise compared to signal. Your quality will degrade simply because you are overwhelming your context window. All right. Which of these are not a real cause of context rot? Stale information that was accurate last week but isn't anymore. Contradictory instructions across different parts of the context. Token fragmentation from mixed encoding schemas. Irrelevant context that dilute signal to noise ratio. So many people are saying C. Many people are saying D. I have a question for those of you who are saying C, token fragmentation from mixed encoding schema. Why do you think that causes context rot? Or why do you think that does not cause context rot? Because in this question, I can see so many different answers. So let's look at it one by one. If you have contradictory instruction, it will cause context rot, correct? Which means B is not the answer. it will definitely cause irrelevant context that dilute signal to noise ratio. That can also cause context rot, correct? That is literally what we discussed in the last question. Stale information that was accurate last week but isn't anymore. This can also happen. You know how in our email responding agent, let's say our or chatbot, let's say the policy changed. So last week the policy was correct. This week it has changed. So probably this is one answer. But there are many other things which you can imagine which may not cause context rot, but these three will definitely cause context rot. All right. Yeah, encoding schema is just like the way you convert your words into tokens and tokens into vectors. What is the primary difference between prompt engineering and context engineering? It seems like many options are C. But yeah, prompt engineering is one static text which goes into the LLM input. In context engineering, we have dynamic inputs such as the input from RAG, output which comes from the tools, and so on. And then there are persistent instructions in the form of system prompts. And then there are markdown files which can act as memory. A customer support agent has a system prompt saying, always be empathetic. After 15 turns of conversation, it becomes blunt and robotic. Why? Yeah, Sriharsha, as you said, system prompt is definitely getting diluted. This you might have noticed in ChatGPT, right? Maybe this is one thing which all of you have experienced 100%. If you keep on running in this, running your instructions within the same chat, it will keep accumulating those conversations into the context, and then the context rot happens. Now, last two questions. So your RAG pipeline retrieves 5 documents and places them in this way. So first goes system prompt, then you have 3 documents from RAG, actually 5 documents from RAG, then you have user query. This is what we saw earlier. Which document could be least effective? The document that could be least effective is whatever is there in the middle. So, and this is how we assembled in the exercise. Please note, in the exercise, we had first the system prompt, last the user input, in between everything like the conversation history, memory, RAG, tool info, etc. So here, some things in the middle, like anything over here can be, problematic, but based on what we saw in the paper, doc3 could be the most affected. This is not a rule, by the way. It's something which maybe in some cases doc4 may get affected. Maybe sometimes information in doc2 may get affected, but on an average, middle items can get affected the most. The last question, which context engineering operation does a RAG pipeline primarily perform? So this write, compress, isolate, select a framework we are yet to discuss in detail, but just read the question and try to understand based on your logic. It generates new context from the knowledge base. Is it this? Because of course, RAG can add more info into the context through whatever it does, right? But is that the case, or is it compress? It reduces documents to fit the context window, because you can provide large document for RAG, and then RAG will produce chunks and it can add it into the context window. Or is it selecting? It chooses from information to include from a larger corpus. Isolate. Most of you have said C. That is correct. So I think that brings us to the end of the quiz section. It's also on the website, which I will be posting in our course website. And for those of you who are in the engineering plan and industry professional plan, please note that I had posted yesterday a Discord server link. Please join that. I don't think everybody has joined yet. Please make sure that you have joined the Discord. We will continue the kind of conversations there. And I want you to go through the Google Colab notebook once before tomorrow's lecture. And tomorrow, we will be discussing about how to craft the system prompt in a very effective way. Because if you think about whenever you are working on Claude code, the first file that you will be working on will be something like claude.md file. And this claude.md file will have everything about the system instructions. The Discord server link will be available only to the engineering plan and in the industry professional students. I have already posted that in the website. Today's recording, it will take some time to process because it's been almost a month. And anyone who has a question, please feel free to put it in the chat. Because of the size of the call, unmuting option won't be there. But feel free to add a question and add the question in the chat. What else is there? Yeah, is conversation history persisted or stays in the memory? Very good question. So there are two types of conversation history, right? So in the example of email reply agent that I discussed, there are two types of conversations. One is the conversation of every single threads that happened over the last 1 year. Obviously, that you cannot put in your persistent I mean, you have to store it somewhere, but you have to also compact it in a way that if some information is needed from that, you have to retrieve it quickly. So what we have done is, if there are 10,000 email threads stored in JSON files, such that those JSON files, each of them are 10 to 15 megabytes, and you have 10 such JSON files of 250 megabytes, you can't use it directly. So what you do is you go through it, you ask the LLM to create markdown files, which finds my writing preferences, which finds my style of replying to technical and non-technical questions, etc. And it should create its own idea, which is a much shorter summary of what all has happened in those entire 10,000 or 3,000 threads. This is one memory which is stored as a markdown file. The second one is the recency. Recent, let's say 30 or 40 or 50 conversations have so much more value, right? So now where should I store this? That maybe I will store as such as JSON file, or I will convert the JSON format into markdown file or XML format. And that I will have separately accessible for the large language model, because storing just 30 or 40 conversation is not too expensive for my context window. But storing 250 megabytes worth of JSON files into my so that it can be retrieved into my context is very expensive. So so how is state management done here? So in that particular case, what I have done is I have the following things which are coming in from the memory. One is the recent history of my feedback. How has I given feedback based on last interactions? Second is how has the last 20 interactions gone between the email reply agent and the customer. That is the second thing. Third thing is a detailed summary of last 10,000 or last 5,000 conversations which happened over last 1 year. And third is a compressed information about all the, let's say there are 100 or 150 courses or whatever on the website, a very compressed, concise format of that. So these four things I am loading into my state for context, but this is all very concise. But on top of this, I'm performing RAG to retrieve the best match courses. I'm performing RAG to fetch the most relevant email for the current conversation going on. And I'm also performing RAG to find from the several dozens of feedback that I have given to my chatbot, my email agent in the last, let's say, 2 months, what all feedback are relevant for the current ongoing conversation. So there are different, so for the state or memory, there are a bunch of things. But on top of it, if I need more information dynamically, I have added RAG on top of it. Okay, so I think we can wind up. So one important detail that I need to mention is the things that I will be posting today. One is lecture video recording for the engineering and industry professional people. I will be posting Miro boards, the code file, the website link, which will be different one which I'm posting. Then all of this I'll be pushing into a private GitHub repo that also I will share. Also Miro I will be sharing. For the free folks, you will get access to the video. Video I'll be anyway posting sometime later on YouTube as well. So thank you so much. Really, please try the Google Colab notebook. Please have your API keys ready. If you did not have it today, by tomorrow, please have it ready. And this experiment, if any of you are interested, just try this once. This repeating the prompt. I think this is very easy to try. Like repeat the prompt twice or thrice and see how the quality improves while your cost is doubling. We can discuss about so research plan, what I'm planning is we have different research topics which are related to context that we want to work on. And the goal here is to work such that we can target some workshops which are part of, not part of, which you can see from here. Just go to openreview.net. So what we usually do is we work on different projects, and whichever is relevant to whichever workshop we submit to those workshops. So recently, a couple of our papers got accepted into ICLR workshops. So the main paper, like main conference like ICLR or NeurIPS, it's very, very difficult. But if you are interested in research, you can just let me know. I had sent an email yesterday with detailed instruction on how to move from engineer to research plan, but just drop me an email at hello@vizuara.com. I'll be happy to respond to that regarding whatever query. So next lecture is about system prompt. The lecture after that is about RAG. The lecture after that is about MCP, and that will be covered this week. Next week, primarily, we will do things which will help us in the building. So for building, I'm planning a very exciting project. I really want all of you to be ready with hands-on skills by then. So thank you so much. We will meet again tomorrow, same time, 9:30 a.m. IST. Have a good rest of the day and try out things on your own, and happy learning experience. Bye.